Hello students, I'm going to solve a tricky organic chemistry problem that covers named reaction, reaction mechanism, and also some other basic concepts of organic chemistry. Why don't you give it a try first before I show you the answer? If you have got the right answers, then you have nailed the question. If you don't get the answer, that's totally okay. I'm going to help you with that. So let's get started. Compound I, a dihalocyclobutane compound, reacts with metallic sodium in dry ether, forms compound J. When you see this combination, you should know that it's about the Wurtz named reaction. On heating forms K with the molecular formula C4H6. 1 mole of hydrogen bromide reacts with K to give two compounds L and M, and they have the same molecular formula, but their quantity is different. One is a major product, the other one is a minor product. Then, what are the structures of J, K, L, and M? In questions like these, most of the time, the options will help you to predict the structures of the molecules. J is given as a bicyclic compound. Why did they give like this? The reason is when a dihalo compound undergo Wurtz reaction, we generally consider them as a free radical reaction. What do you mean by free radical? There is a homolytic fission of the bond. That's why we use a special kind of arrows called as fish hook arrows like this, isn't it? And then what happens? Since the two electrons are close to each other, they can share the electrons like this, and it's forming a bicyclo compound like this. This is a possibility, right? In Wurtz reaction, generally two alkyl halides react to form an alkane. But since the reactive centers are within the molecule, intramolecular reactions are more favored as compared to intermolecular reactions. This is applicable for almost all the reactions. Remember, intramolecular, that means what? If the reaction is taking place within the molecule, it is more favored because in case of intermolecular, the molecule should come closer and then they have to align in proper three-dimensional space and then they have to react. But in case of intra, they are in close vicinity. They are within the molecule. Reaction is more favorable. That's why it will undergo intramolecular Wurtz reaction. Hence, you are going to get a cycloalkane and it's called bicyclo. Why so? Because you see there is one ring here, the other one ring here, which are bridged between these two carbons. That's why we call such compounds as bicyclo compounds. And how to name bicyclo compounds? Very simple. You write down bicyclo first and then write a square bracket. Forget about it for now. Count the number of carbons. 1, 2, 3, 4. 4 generally we call it as a butane. So write that part. So it's a bicyclobutane. But how many carbons are there on each ring? So in order to understand that, from this side we have one carbon. From this side we have one carbon. Between these two there are no carbons. Therefore we write it as 1.1.0 in that decreasing order. Therefore the name of this molecule is bicyclo 1.1.0 butane. Option A is correct option. What all you have learned here? The reaction mechanism of Wurtz reaction and also the UPAC nomenclature of the bicyclo compound. Once you know the structure of J is this, let's see what happens next. In the next reaction, the bicyclo compound is heated at very high temperature, 250 degrees Celsius. Then what should happen? See, if you know the reaction, it's well and good. You can directly write the product. But let's say assume you don't know this reaction at all. Then what might happen? K structure is butadiene structure. Can this be possible? Yeah, because this is a isomerization reaction. What do you mean by isomerization reaction? When a molecule is heated at a high temperature, there is a breaking and making of bonds, and the product form will also have the same molecular formula, but its structure is different. For butadiene molecule, what is the molecular formula? So we have 1, 2, 3, 4, C4 carbon, and how many hydrogens are there? 6. Therefore, C4H6. What about this molecule? This also has 6 hydrogens like this. So it is isomerization. So there is a possibility that this butadiene, 1, 3 butadiene is the product. You can straight away go ahead with B as a right option, but I'm going to give you reaction, how this is happening. These reactions are also called as ring opening reactions, popularly known as pericyclic reaction. In pericyclic reaction, the closed ring will become open chain will become closed ring. So how that will happen here? Very simple. So you see this bond will break here and it goes here. The moment it goes here, this carbon is becoming pentavalent, not possible. So immediately what happens? This bond will also break. So this is called as concerted mechanism. That means it happens in one step. So how are we going to write this? See, this bond is intact, right? You write that as it is. What happened here? This bond is gone, but there is a double bond like this. What about here? This bond is gone, but this is becoming double bond like this. And what is this? It's nothing but the butadiene. If you rewrite this molecule, it's nothing but the butadiene. Hence, option B is correct. The reaction of 1, 3 butadiene with hydrogen bromide is an electrophilic addition that produces mixture of two products, that is L and M. The product ratio depends on the temperature due to kinetic versus thermodynamic control. The low temperature favors 1, 2 addition. 1, 2 addition refers to when the hydrogen goes to this carbon, the bromine goes to the second carbon, like this. It is simple addition of HBr across the double bond through Markovnikov's addition. However, at a higher temperature, it favors 1, 4 addition. What is 1, 4 addition? When the hydrogen ion adds to the first carbon like this, the carbocation formed here is stabilized by resonance, and then we are going to get the carbocation here which is attacked by the bromine. And this is called as 1, 4 addition because the hydrogen is adding to the first carbon and the bromine is adding to the fourth carbon. Which is major and minor? How to decide? Look at the reaction condition. For kinetically controlled products, the low temperatures are preferred, but there is no low temperature mentioned here. That means what? This is a thermodynamic control addition reaction. Under thermodynamic control reaction, 1, 4 addition is more favored. That means what? This should be our major product and this should be our minor product. Which is a major product here? L is the major 80% and M is the minor. Verify the options. L is given as 1, 2 addition, but that is not correct. L is 1, 4 addition product. Hence, this is not correct. M is given as 1, 4 addition. That is not correct. M is 1, 2 addition. So, this is incorrect. Therefore, among the four options, only A and B are correct. So, students, what all topics we have covered here? Wurtz reaction and its mechanism, and the ring opening reaction, followed by thermodynamic and kinetic control product formation. I hope I made this clear to you. And if you still have any questions, you can drop your questions in the comment box. I'm going to help you with that. And don't forget to solve the question and comment your answers.